Good afternoon, everyone. So today we are going to have a presentation on detecting crowd-sense data falsification attack using outlier detect by DBSCAN algorithm. And my project partner is Sukumar Sharma, and we are working under the guidance of respected Dr. Mrs. Ningmingla Marchang. So our content will include the introduction part, literature survey, proposed methodology, flowchart with process, result and discussion, and finally the conclusion. So let us move ahead to the introduction part. So clustering is an unsupervised learning method in which a group a set of data points in a way that similar data points are grouped together, and hence it does not contain any labels for the data points and the number of clusters to be told beforehand, unlike k-means where we have to specify the number of centroids. So clustering can be divided into three subcategories: partition-based clustering, hierarchical clustering, and density-based clustering. So in our particular project, we use this density-based clustering because both this partition-based clustering and hierarchical clustering both fails in creating clusters of arbitrary shape. So they are not able to form clusters based on varying density. That's why we need DBSCAN clustering. So DBSCAN density-based clustering identify distinctive groups or clusters in the data, and based on that idea, that a clusters in data space is contiguous region of high point density separated from other such clusters by contiguous region of low point density. So let us look at an example. Here we have data points densely present in the form of concentric circles. We have original data set, k-mean clustering, hierarchical clustering, and the DBSCAN clustering. So here no specific clusters. K-mean and fail to cluster the. Also, they were not able to properly detect the noise present in the dataset. So now let's take a look at the result from DBSCAN clustering. DBSCAN is not just able to cluster the data points correctly, but it also perfectly detects noise present in the dataset. So let us move ahead to literature survey. Density-based algorithm for discovering.
Francis.
Yes, sir.
You can skip this literature survey part because we have already discussed. We have listened to you this content
Okay.
Earlier. So please skip this part. Please skip this part.
Okay, sir. So let us move to proposed methodology, and we had given a large data set that is .csv file, which is comma separated values, where it consists of 5 columns, which are days, time, latitude, longitude, and temperature. So the provided data set we had to falsify. That means we had to add noise to the column of temperature in order of 2%, 4%, etc. from the actual data set. And also we have to set the mean points values for each percentage of outlier added as in increasing order, that is m equal to 3, 5, 7, 9, etc., along with the nearest neighbor, which is also known as ns, equal to 120, 160, 200, 320, and 400, as randomly and run with the DBSCAN algorithm. So by using that falsified dataset .csv file, we have to detect noise or outliers using DBSCAN algorithm. So the working of DBSCAN algorithm. Initially, all data points are unvisited, so we first go to the first data point and see if it is a core point or border point or outlier point. If it is a core point, we mark as visited, and then we make a cluster, and then we check other point. If it is core point or border point or outlier point, if it is outlier, we simply ignore it and we will not include it into the clusters. So if one of the point is visited and is a core point, and next point is discovered as a core point and also visited, and these two core points are neighbors of each other, and we put both these core points in same clusters. In this way, cluster is propagated. So we also calculate the true positive rate, which is also known as TPR, false positive rate, recall, precision, and accuracy of the outlier detection. So we have added 7 times loops for each percentage of outliers, added into dataset, and run 5 times inner loop for each mean points and NS value. And inside every 5 inner loops of NS and MS, we also doing 2 times loop for every NS and MS values. So there will be 7 into 5 into 3, which is equal to 105 times loop we will run. So in every 5 inner loop iteration, we will find the accuracy, TPR value, FPR, recall, and precision. After that, we will compute the average accuracy, average recall, average precision, average TPR, average FPR for each iteration, and stored in 2D matrix for each percentage of outliers. And based on if we have to plot the graph for percentage of outlier added versus average accuracy with respect to its mean points values. Same way, we also have to plot the graph for percentage of outlier added versus recall with respect to its mean point values. Also for percentage of outlier added versus precision with respect to its mean points values. And at last for ROC, which is FPR versus TPR, ROC curve for showing the best mean points which has less FPR and high TPR on our model. So from the graph, we will be able to show how well the code is working as when we increase the percentage of outlier added, then the accuracy drops like this. And from this on, I will call my project partner Sukumar to proceed our presentation.
Hello, good afternoon, sir. Am I audible, sir? Hello.
Yes, Sukuma, you are audible.
And sir, screen is visible. This this flowchart.
Yes, it's very much visible. But thing is that there is no clarity on your.
Okay, sir. I will share from the screen
so
side.
Lengthy that yes. You could divide the flowchart into 2 parts, and that way you could have conveyed it more clearly.
Sir, now it's visible.
Let us wait for a while. It's not yet visible, but your voice is clear.
Sir, it's visible.
Not yet.
Screen?
Not yet. Now it's fine. But your diagram is so lengthy, you know. The font is small because of this larger diagram. So could you zoom in so that we could see it?
Now it's visible.
Yes, visible.
Yes, sir.
Yes.
Sir, initially,
Kumar, can you zoom in more?
Yes, sir.
Can you zoom in a bit more?
Yes, sir.
Yeah, it's not bad. Yeah. Now it's good. Can continue with this. Yeah.
Yes, sir. First, randomly we are choosing the MS, NS, and the percentage of outlier to be added as randomly, such as the MS value as randomly we are taking as 3, 5, 7, 9, 11, and NS value we are taking 120, 140, something like that, and then we are adding the percentage of outlier to be added to the original data set, which was 5030 data points. First of all, we are going to falsify the 2% which from the 5030 data points, then it will be of 101 data points. Then for this we are calling the function called random falsify n, where this percentage of outlier added means 2 is assigning to the n variable, and then the original dataset which was sensed value original.csv we are reading, and then falsifying this dataset into the errored original to CSV, and then we are creating another index of error CSV for storing the index of only the falsified dataset which was present in this errored original to CSV. After that, this errored original to CSV, we are assigning this data frame into the data frame, and then we are calling this DBSCAN method where we are passing the data which was this errored original to CSV, and then we are passing the MS and NS value which were initially given as random, and then we are storing the index column of the index of error, this one, and then storing into the list, and then we are calling the make model function where we are passing the NS MS data, and then we are doing the standard scalar dot fit transform data for fit and transform the data DBSCAN, and standard scalar for transform data such that its distribution will have mean value 0 and standard deviation of 1 for the scaling, and then we are doing this nearest neighbor and passing the NS value to this function for calculating the distance, for calculating the k nearest neighbor, so that how many nearest neighbor we have to consider in terms of distance by Euclidean distance. After that, we are passing. After that, we are doing the DBSCAN function. This is the actual heart of the algorithm, where we are passing the EPS value by the predefined function called distance.mean. It will automatically create the elbow band method and then assign the value of EPS to this EPS parameter, and then we are means we are assigning the MS value to the mean sample, and then metric we are using the Euclidean, and then we are labeling all the then we are doing the model.label -1 for the outliers. The -1 indicates the outlier which are present in the which are present only for the outliers, and then we are printing the outliers, and then for the number of clusters we are printing the labels and subtracting the -1 which was the outlier, and then we can print the number of clusters which were formed. After that, we are calling another TPR method where we are passing the outlier list which contains the actual outlier data frame, and then similarly we are doing the FPR and passing the outlier list in data frame of outlier, and then we are calculating in TPR the TPR, and then calculating the average of that TPR, and similarly we are doing for the FPR. And from this calculation of average TPR and average FPR, we are plotting a ROC curve for better value of MS in the ROC. Similarly, we are doing the accuracy list and calculating the average accuracy. Similarly, precision, and then average precision, and then recall, and then average recall. From this, we are plotting the average recall versus percentage of outlier added, and from precision, we are plotting average precision versus percentage of outlier added. From recall, we are printing recall versus percentage of outlier added, and finally we stop. After that, the result and discussion as shown in the plot. First is the ROC curve which were plotted between the FPR and average FPR and average TPR. We can see this area section which has the good TPR and the bad FPR. So we can see that the triangle which is the m equal to 5 has higher TPR and low FPR, means this value is the best. So as you can see, as the value of m increases, the FPR also increases, which is not good for our model. As for accuracy versus percentage of outlier added, we can see the this triangle line is best. M equal to 5. As the percentage of outlier increases, the accuracy drops. As you can see that M equal to 7 is the last, means lowest. So accuracy is best for the minimum value of M. After that, we are plotting the recall versus percentage of outlier added. Similarly, we can see this M equal to 5 is better, and then precision, where where precision can never be 1, and so the zigzag line is mostly suitable for this one and this one. After that, the output screen, for the first iteration, we are doing 4%, and then this is the TPR, FPR, precision recall, and we are summing that TP plus TN plus FP plus FN is equal to the total number of data points which was originally in the data set is similar, and then it will run for 7 times, and the last iteration, which was 7, and it will run for 7 times, and then inside that it will run for 3 times. So total it will run 105 times. So the runtime of execution of the program is 102.587 seconds. So finally, in conclusion, we have successfully implemented the DBSCAN algorithm till now. We have plotted a graph successfully between percentage of outlier added versus average accuracy, precision, recall. Also, we had implemented ROC curve for determining the best value for mean samples, which has high TPR and low FPR. Here we can see that when percentage of outlier is increasing for each different mean point value, the accuracy drops. As a conclusion, the DBSCAN algorithm is far better as compared to k-means and other clustering algorithm because it can nicely handle the outliers. These are the references. Thank you, sir.
Francis and Sukuma, I'll start with your reference section. Your references have very less works, you know. The reference section must include at least 10 or 15.
Sir, we had included in the report, sir.
But in slide also you should have put it, isn't it? This is the right way to present. Oh, references section must have all the references that you have done, that you have referred in your report. First point. Second point is that you have only implemented DBSCAN, isn't it?
Yes, sir.
The whole framework is only related to clustering.
Yes, sir.
Have you ever come across automated clustering? Because you claim that DBSCAN is working well for your work. And as you know, that there is a theorem called free lunch theorem, whereas an application is always, a model cannot be claimed as robust for all applications. In other words, every model is every model cannot be invariably used for all variety of applications. That's what no free lunch theorem indirectly conveys. So that way, instead of claiming DBSCAN is better than the others, you can come up with a DBSCAN with automated clustering. Have you ever heard about automated clustering?
No, sir.
Yes, sir.
Okay. So while you have started working, did you survey that what are the other varieties of clustering available in the literature?
Yes, sir. There are various clustering methods such as k-means and hierarchical clustering. So as compared to this clustering, the k-means and hierarchical clustering are highly efficient with the spherical shape clustering. But when it comes to the arbitrary shape, and then DBSCAN perform very efficiently and handle the noise very perfectly.
Okay. Let me ask Francis a question. Francis.
Yes, sir.
Francis, how your self-organizing map is different from DBSCAN? Self-organizing map is also a very powerful clustering technique, and it is very much flexible to noise also. It could handle noise better. And could you see the usability of self-organizing map for your data?
Can you repeat the question, sir?
What I'm asking is, looking at your conclusion, you claim that DBSCAN is better as compared to other techniques like k-means. So when you compare, I mean, when you claim such things, you must implement it and you come up with the result. I believe that you have also tested the k-means with your data, okay? But given the volume of work, you cannot implement only one clustering technique because there are so many inbuilt packages are available to implement one technique, So in such scenario, the way you carried out your work, we must expect at least 3, 4, 5 techniques to be implemented and come up with a conclusion. Because gone were those days where people are writing code from scratch. Now you have many inbuilt packages for all standard algorithms, So in that sense, my question to you is, Francis, how much coherence self-organizing map is applicable to your work? I'm sure you studied coherence self-organizing map, a very powerful clustering technique, an unsupervised learning method. Am I audible, Francis?
Yes, sir, you are audible.
Yeah. Do you find any applicability of coherence self-organizing map for your work?
Sorry, sir, I don't much aware of it.
Okay. Okay. I may request other sirs and madam if they have any queries.
Yeah, Sukumar and Francis, yeah, DBSCAN, okay, it works fine, but yeah, unless we really compare, we can't really say for mobile crowd sensing whether it's the best. Anyway, whatever it is, what I have in mind is that if you really want to publish your work, you'll have to do other what is that clustering methods, which Sir also has suggested. Right, so that you can compare, give a comparison and say, yes, DBSCAN is the best.